Hi, in this video I'll show you how to draw a winding in COMSOL Multiphysics. Normally if we want to draw a complicated 3D object, we use a sophisticated 3D design software like Inventor, SolidWorks, CATIA, I don't know, other software, and draw the geometry in those software and then import the geometry into COMSOL. But sometimes maybe you don't have those software on your computer and you don't know how to work with them. So you want to draw your geometry in COMSOL, even though the geometry is a bit complex. So that is what we are going to do today. And the task is to draw these two geometries. This is one toroidal winding and this is a transformer, a primary winding. So here I meshed it already, but we can also see the winding. And here we have the transformer winding. So we see how to create these two examples. First, I will create this example. I first create the core and then we build the winding and then we do this example. Okay, so now I create a 3D model. In this example, we are only going to draw the geometry, but anyway, I select the physics and study, but we are not going to study anything. Okay, I select the size as unit to be millimeter. First, I'm going to create this profile and then I will extrude the profile to create half part of the core, and then we mirror it and we'll create the other half. So we use a work plane, and then in the geometry, right click, polygon. Now I know the size of this core if I remember correctly, but you should know the size of the core, whatever you want to draw. I just keep drawing it. So this is the outer part. Then we have 70, 0. Okay, so we have created this profile. So now we right click on geometry and we select extrusion, and I select this face and I extrude it 30 millimeter. And of course this one should come here. Then we already have the core. Now we can mirror this, right click, transform, mirror, select this one, and we want to mirror with respect to y-axis. This should be 1, should be 0. You can keep the input object, so then now we have the whole core. This is UU core, ferrite core usually. Okay, so now we have to make the winding. First thing that I will do is to create a path, because I will create a cross section and then I have a path. Then I will sweep this cross section over that path. So first I will create a cross section. So right click here, a new work plane. I want the plane to be XZ, so over this plane. Here I create a rectangle. So I put this path like around the core, so a rectangle with a size of 22, 32, minus 1, minus 1. I add fillet. Radius 1 millimeter. I convert this into curve. Okay. Now we are going to add the cross section of the wire that we want, so another work plane. And this work plane should be there so that we draw our cross section and then sweep it over this. So here I create a circle. Maybe the radius is 0.3 millimeter. And the position is here. Should be -1. And I also add a point here at this point. -1. Okay, so I'm going to create another point. So I will shift this point upward to another point. -1 and y is 1. Because we have this cross section, it's going to sweep over the path, but we don't want to come back to here. We want to go a little bit up. So that would be a guide point that we want to reach to that point. All right, so now we have this. Now let us split that object that we have here so that we get access to it. So that is good. Now what I want to do is to move this little part here and then connect these two together so that we have a path that goes upward. So first I create a move. And I plan to move this little part up here. So I will move in the y direction 1 millimeter. And I don't want this, so I delete that line. Here you select edge and delete it. And then we connect, I zoom out. We connect this one to here. So we create a line segment. And then this is the initial point. This is the end point. So we have the line segment. Okay, so this is the path. So we have the surface, we have a path. So we are going to sweep this. You right click on geometry, select sweep. So we have to select the face. The face that we have is this. And we should select a path. I'm just left clicking and selecting this. All right. So we just build it. So basically, we had this surface, we sweep it around that path, and now we have created already one turn. Now what I'm going to do is to hide this newly created. Okay, so first let us maybe combine this together, or should I do that? Let us hide this first. Okay, because I don't want to have these lines in my model. Later on, when I want to create a mesh, then this creates trouble. So I right click, delete entities. Now that we already created the first turn, we don't need these edges. So you select edge and we select all of those. Okay, so we can delete them. And also I will delete these points. So we bring back the hidden parts. All right, so we have created already one turn and there is no other uh, lines inside them to create trouble for meshing. So the next stage is basically to create an array. So right click, transform array. And you select this object. Because we have shifted this only 1 millimeter, so the distance between this lower part and upper part is 1 millimeter. So we have to keep the distance 1 millimeter. And let's say I want to create 10 turns on top. So this would create 10 turns, and I can create another array. And in this case, we move -1, and then we create 10 turns on the lower part. So we have already created the winding, and now we can, for example, extrude it from the direction that we want. Maybe from this direction, I will extrude it. Because later when you want to do the analysis, you need to have some terminals to send the current in. Okay, we can directly send it here, but if we put outer box on it, then the current should come from external surfaces. All right, so I'm going to extrude in this direction. So first I'm going to remove this last part and then extrude from that surface. So I want to basically get rid of these and extrude from that surface. This is one side. Because this whole turn is now one unit, I have to split it to be able to delete it. So now I first split this and then right click, create delete. And here I can delete the domain. So this one deleted, and now I extrude from this part. Okay, so I right click and select extrusion. Here we select faces, select this face. Want to extrude maybe 30 millimeter. And so that would be the first connection. For the lower part, I don't want to extrude in that direction. I want to also extrude in the same direction as the top one. So first I move one of these here and then rotate it. So let's see what to do. Create a split. And then we can select move. Keep the input object. So I want to move it -1. Okay, but then now I rotate this. This object, the axis of rotation is Z axis. That's okay. We want to rotate it 180 degree. That is also okay. So the Y is now, what is Y? If we come to this is the Y, it's -9. Y is -9. It seems. And so Z is 0, X is -1. Okay, so this one, is it rotated properly? Yes. So now I have that one, then I can extrude another time. Face, extrusion, this is the face, and this is maybe 25, 28 millimeter. Extrude. Okay, so now we have basically the winding, and we can put a box, bigger box, and can extend this extrusion to go outside the box, and we can send the current in and current out and do whatever analysis that we want. Now I mesh it and we see whether the mesh works on this or not. Okay, so the mesh works, which means that the model doesn't have much problem. It seems, of course, at these interfaces, we have a lot of meshes. Yeah. Okay, so since we have a lot of meshes here, maybe we should correct this. So I right click on geometry, I make a union. Now we can select all these turns, remove the interior boundaries. We create one unit. And now we can right click on geometry and add remove details. Okay, so now if we create the mesh, all right, so now if I zoom in on this, you notice that we do not have many extra meshes around those boundaries. So this mesh is right now okay. All right, so this is the first exercise. Now we continue with the second exercise. Okay, so now we continue with the toroid. Again, I select the 3D. So in this case, first we are going to make a core. So this is the axis symmetry. I put a rectangle there with fillets and then we revolve it. So we get the toroid and then we add the wires. Unit, we select millimeter. So a work plane. Then I create a rectangle. So this one has 12.6 millimeter. Height is 12.6, width is 10, and x is 10. This is the rectangle that we have. I add fillet. 1 millimeter. Okay, so now we have the cross section. We can revolve it. This is the cross section, and we want to revolve it obviously around the y-axis. So this would be the toroid. Now again, we first define a path, and then we put the circle, the cross section of wire, and then we revolve. So I create another work plane. This is a good work plane. All right, so now I add a rectangle. So height 14.6, width 12. This one maybe 9, and this one is -1. So the rectangle goes there, and we add a fillet. Okay. So the first work plane is now done. We go back here. Um, this is here. So now I need another work plane. I want XZ axis. XZ axis, that's okay. So I will create a circle. So let's say the radius of the circle is maybe 0.5. And the position should be 21. And then I also add a point in the center of this. I now rotate this point reference to center. I will rotate it here. So I want to put 40 turns on this. 40 turns is 360 divided by 40, gives us 18 degrees. So now first wire come here and the second wire will go there. No, 360 divided by 40 is 9. Sorry, put 18. So this one comes here. Okay, so now we go back to geometry and we split. Maybe here, we go back here, we right click and convert this one into a curve. And now we go to geometry and split. I select this one and I split it. Okay. So How would it rotate? It would rotate like that. One goes there, comes here, and then we want to bring this one here. Okay, so now I create a rotation and I select these two edges, this little part and this little part, and we want to rotate it. This is the y-axis, so we want to rotate it along the y-axis with 90 degrees, both of them. Okay, so this one goes there. I delete this extra edge. Here you should select edge. This one delete. And then I also delete this one. Two of them should be deleted. Then we create a line segment from here to here. That's one line. Okay, sorry, this one and this one. Okay, so now I create another line segment. And then we connect these two together. This one and this one. Now we have already formed the path. So now we can sweep the cross section over that path. This is the cross section. And here we have the, what is this? Here we have the path. All right, so this one can be created. Some trouble because we have to go reverse direction. That's good. Now I can hide this and delete whatever that we have used to create this first turn. You don't want to leave those lines inside the geometry because later, as I explained before, when you want to create meshes, then they can create trouble. So right click, delete, edges, this, and also I will delete this point. This point in the middle of nowhere. That's good, so we bring back the hidden parts. So we have one turn now. Okay, so now we can basically replicate this one turn. So I create a rotation. We select the turn and we want to rotate it at 9 degree. The axis is there, so we should select y-axis. This is not 9 degree because we want to create many of them. So 0 steps of 9 degree, and then let's say we don't want to create everything. So for example, I don't know, 36 degrees we don't want. So it's 360 minus 36, 324. So then we have it like this. And now the last part is to basically extrude this last part. So first I am going to split it. This part I split. Okay, so now I'm going to rotate this part here. So we create a rotation. And then we had 36, but 19 degree is gone, so 27 degrees. And the axis of rotation is in the center of this toroid, which is y-axis. So this one comes there. Okay, so now I want to rotate this one along here 180 degrees so that the direction of this face is toward left. So we create another rotation, and the axis of rotation obviously is in the inside the toroid, so it's in the y direction. So we should select 180 degree also. I want to rotate it, and the x is so it's here, so we can come to this cut plane. Yeah, now this one, so we want to, it's 21. So x is 21. So if I rotate it, then as you can see, it's like this, and it comes like that. So now we can extrude the other parts. So extrusion faces this one, maybe 10 millimeter. Can also create another extrusion faces this one, maybe 12. Okay, so this is basically the winding, a toroid. And now we can try to mesh it and see whether it works or not. All right, so this is our toroid with nearly 40 turns around it, 37 turns, I think, 38 turns. So you can apply the same strategy to draw any windings that you want, and then you can analyze transformers, inductors, or whatever things that you have in mind. Okay, bye.